Okay. Let me have a volunteer. Thank you, Robert. Come up here. Okay, so we have been talking about, if you'll think about the video from yesterday, what was it focusing on?
It was water.
Water. What about water?
Pollution.
Pollution. What else? So we talked about Engineer Without Borders. What the engineer, when she was going around the world, what was she doing?
Going outside.
Going outside, cleaning what? So cleaning the bad water. Here, I have dirty water. I have dirty water. It is a mix of water, dirt, a little fertilizer because I got it from my cactus at home. So, and then I have my pour over coffee. So what we're going to do, this is a fine mesh strainer. I want y'all to see the difference. We might have to do this a couple times. This might not be a pour over and it's all clean. So Robert, what I want you to do, it's going to shake it up a good bit. I want you to pour the water in here and we're going to watch it. I will do it. Here. Can you see? It looks like gravity. Hey y'all. So what do we see about the water?
It's getting clean.
It's getting clean. Some of it's coming through still. But is it cleaner?
Yeah.
Wow.
Sure.
So think about whenever you made your water filters a couple weeks ago. What all do we put in there?
Dirt.
Coffee filters. Rocks.
Cotton balls.
What?
Cotton balls.
Cotton balls. What else? We had the small rocks and we had the big rocks, right?
Pebbles.
Which do y'all think were more effective?
Small.
The small one or the big? That little peat gravel stuff? One thing we didn't use that I wanted to use. Clay. Have y'all ever heard clay is good?
Yeah. Clay is fun.
Clay is fun to play with.
You can make like a sifter. You can make a sifter.
So this is still not clear. So if we were, let's say we were to add other things, what would we add? Y'all just listed some of it for me. Cody. If we were to add things here to increase filtration, what would we add? Cloth. Yeah. Clay would be good. What now? Gravel. Maybe sand. We would have to add it some other things, but sand could work. Cotton balls. That would work. Filters. Yeah. So we have this strainer, and then we have another strainer. So the mesh is just another thing, because all you're trying to do is separate. That is all you're trying to do here. So, can't really see, but there's a lot of dirt left in this. So let's pour this back in. Let me get you to filter it out one more time. Can I get another volunteer to filter? Yes, come on, Kameo. Okay, so go ahead, and y'all can already see the water. It's still dirty. I still wouldn't drink it. But, is it better?
Yes.
Okay, Kameo. Thank you, sir. Okay, and that is another thing to pour it slowly. I know, because I make pour over coffee in this, I'm going to have to intensely wash it. If you pour it all at once, it's just going to come down. It's not really going to filter much. It's not really going to pull a lot of the coffee out of it. I think it did. Once a bit clearer. So, what do we see? Thank you, Kameo. You can sit down. So, okay. So, what do we see? Do we want our water to have just one filtration process?
No.
Or do we want multiple?
We want
How many?
multiple.
Multiple times?
Times a million.
Times a million. That's a lot. That's a lot of filtration.
Times a billion.
Times a make our water more safe. Remember yesterday, let's think back to the video. She was saying there's a lot of chemistry involved. You have to test it. You have to see how much, whatever is in here. Because we have elements in our water that are not, you have calcium, we have other things like that. What did I say was good for our teeth?
Fluoride.
Fluoride. Yeah, so we add fluoride to the water.
Toothpaste.
Well, yeah, it's in toothpaste.
You cannot add toothpaste to the water, my man.
Okay.
Milk it. Mouthwash.
Okay, they add fluoride.
Can you die from toothpaste?
It can
Yeah.
poison you,
Oh. You can die for me.
but it would be like a lot. That was very intelligent. Okay,
enough to have diabetes.
so,
Like this.
hey y'all, focus up here, thank you. So environmental engineers are concerned with making drinking water safe for people. They're concerned with treatment facilities, so they design entire facilities to make it safe to drink. Y'all know all of our water is treated, right? It goes through a facility. Did y'all know that? So there are several processes they use. And we talked about coagulation. It was in your notes. So let's look at, let me erase this. So, let's look at the processes they use. I'll write them on the board for y'all. Okay, and I'm going to call on someone, so be ready to define coagulation for me. What does coagulation mean? Matthew.
I don't know.
Okay, I'm going to come back to you. Who else can tell me what coagulation means? You just took a note on it. Grace. I'm sorry, what now?
Hey, buddy.
One more time. Speak up a little bit for me. Good job.
Good morning, citizen.
Here. Okay, watch. Okay. Bunching particles in water. Okay, so let me get you a seat really quick. So it is pulling particles together. So Matthew, tell me what that means now, since you've gotten a definition.
Pulling particles together.
What now?
Pulling particles together.
Pulling particles together. Good job. Actually, I'll just put you one.
Great.
What?
So why would that be important? Why would it be important for particles to be pulled together with our water system?
Because then the water can be healthy.
Okay. Okay, go ahead. So, let's think back to this. I did not have anything to coagulate my water. I just had my particles in there, and I filtered it. I saw what came out. If you have things that can stick together, does that make it easier?
No.
No? Tell me why.
Because it's hard to get out of the water.
But if we're straining the water, we have big particles together. So let's think about sticky rice. So, hey y'all, pay attention please. So if I had told you, because y'all know sticky rice, hence the word, it sticks together. If I told you to pick up 600 grains of rice, they're individual and all on the floor, separated out from non-sticky rice, would that be hard?
Yes.
No,
What if I had
No,
it?
because I wouldn't do it.
Well, it's not stuck together.
No, but no, it wouldn't be hard. It would be sticky.
Okay, well that's where I'm going with it. If we took that sticky rice and clumped it all together into one piece, would that be tremendously easier?
Yes.
Yeah? Tell me why. Why is it easier to pick up one clump of rice than 600 individual grains? Robert?
Because 600 grains takes more time. I have to separate out all of them, and
Mhm.
one time you can just get all 600 in one.
Yeah, Yeah, right, just like the filtration process. I have all these little pieces and particles of dirt and whatever else is in there. If it's all clumped together through coagulation, it's much easier to separate out. So, and coagulant is just the coagulant they use, it's just a little powdery chemical they put in there. So, let me show you all this image. Can y'all see that?
Yeah.
Okay, we are going to trace. Okay, pay attention to this because I'm going to call on people to put this together. I'm going to take it off when I call on you, so pay attention. So, here is your water source. Water source. It goes into the mixing zone where flocculation and coagulation happen. So coagulant gets put in there, flocculation occurs, everything pulls together, okay? Then, everything has been coagulated. It goes into this area. You can see here, the sediment is on the bottom, it's formed into one clump. So you can see that the solids are moved here, the water goes here. What does this remind y'all of, this layering?
Cake.
Cake? Kind of reminds me of cake too, but have y'all seen,
Italian flag.
so let's think back to when I was talking about oil and water and why it doesn't mix. What did y'all tell me?
Oil
Never
and water
follow
don't
each
mix
other.
because water is more dense than oil.
Okay, that's one of the reasons. So, if you took water and oil, you colored them, put food dye in them, would you have two distinct colors?
Yes.
That's kind of what's happening here. So, it's all kind of getting into its little areas. It's all separating out. They're disinfecting it, taking just the water, so we're discarding the dirt, any bad stuff in there, any things that can make you sick, any pathogens. They're getting that out, getting the sediments out, any left over.
Tape.
So, it goes here, and then here. What is this?
The pipeline.
This is us. So when I turn on my filter, when you turn on your filter, when we access water of any sort, it comes to you. So, what I want us to do now, I'm going to ask y'all, who feels comfortable giving me let me take it off. Who gets comfortable giving me the first part? Cypress. What's the first part of our water system?
We grab like all the dirty water and then we put it into like the mixing zone where they put the I don't know how to pronounce it, and then it like flot and then
Here, just tell me the first part. So where is the first place our water comes from?
the sky and like the rain and stuff like that.
Okay, so we have a big pool. The water what? It starts with an S. Starts with an S. Water source. Water source. Good job. Thank you, Cypress. What is Martha's done? Okay, that is our very first step. We pull water from the water source. Where does it go from here? Someone raise their hand. Already gotten it. I want someone else who hasn't answered yet. One. Where? So we pull our water from the water source. Where does it go now? Okay, what now? Okay, so it's going through the pipes. What process? It starts getting filtered. What are the terms? Can someone help them out? Someone that called on. Grace. What? So we're going from the water source, we're pulling them down the pipes like one said. What is happening now? Remember, it's all this dirty water. It has all this stuff in it just floating around. What do we need to do? Put it together. Good job. Who can tell me how it's put together? Cody, can you tell me how it's put together? What's that C word we were talking about? What now? You're almost there. Not correlate. It's It's on your notes. Yeah. Not configuration, you're close. I'm gonna come back to you, Cody. Yes. Who can tell me? It's the C word. It was just written on the board. It's in your notes. They clump together. What is that word?
Clump. Clump.
Y'all are everything at Good job. Who said that? Thank you, Kameo. Cody, tell me what the word is. We just said it. So I was going to come back to you. What now? Coagulation. Good job. Thank you. So, this is where we add the coagulant. This is where, so you've added the coagulant. What's the word? What? Yes, good job. So this is where the flocks start forming. So, let's put this here. So, water's here. Coagulant is added. So we'll start drawing little clumps. So this is little dirt clumps. So, now we have everything in clumps. Where do we go after that? Can someone tell me?
Another pipe.
Okay, another pipe. Vincent, can you tell me? Can you tell me where it goes? So we've got everything, everything has been coagulated. They're in their flocks. Think about sheep, like flocks or sheep. Flock of sheep. Can you tell me what happens after it's all in the flock? Okay. What gets filtered? Okay, the water gets filtered. So how are we filtering the water? What do we do with that sediment? Who can tell me? Thank you, Vincent. Who can tell me what happens to the sediment after? One. Tell me what happens to the sediment. What else? Okay, we have water, we have sediment. We want to clean the water. How do we clean it? What has to happen to that sediment?
The sediment has to like disappear.
Yeah. So the sediment is, what's the word? What? Filtered. So this next step, we have our water supply again. Here is our water. So this is filtering here. Sediment will have green. This is nasty water. This is green sediment. We'll have that going here. Yes. Yes. Here, get the pass off my calendar. Okay. What happens after that? Remember, it was layered. Let's take a quick look again. So we've had the solid removal. Now this is where true filtration, this is the last step. Well, next to last step, we have to disinfect. This is where it's truly free of anything. This is where it's truly free of the dirt, the sediment. So, we saw that, we had a refresher. Someone tell me what's happening now. Amelia, tell me what's happening in this step before disinfection. Okay. It is filtering the water. Can someone develop that? Thank you. Taylor, can you develop that for me? So we've gotten our sediment out, for the most part, the big clump. What are we doing now? What now? So Amelia told us we're filtering it out. So what is happening? Can you tell me? Is this, we've already gone through one filtration. This is our what filtration? We've had one, then the next go around it would be, can you tell me, Taylor? If it's the filtration after the first one, what is that called? First filtration. Who can help her out? Yes.
Second filtration.
Yeah, we're on our second filtration. Can you tell me that now, Taylor? Thank you. So, we've got everything clumped up, but sometimes not everything gets out. I mean, sometimes you have different sediments, you have different particles that might not have gone together. So, you filter it once, you have that, and then we filter again. So let's think about the thing. It has water here. Then we just had different types of things layered. It did kind of like a cake. So we'll do zigs here, we'll do little circles here. Do more. Okay. So then we go to what step? So the very last step, yes, Matthew. Disinfectant. So, did anyone here, I think you are a little young for this, but has anyone here ever heard of the game Oregon Trail? Or played the game Oregon Trail? Do you know what I'm talking about? Okay, so it was a game back, it was a computer game back in the day where you had to get this pioneer family through the Oregon Trail.
Oh, I played it.
You know what I'm talking about? So it was always very common to die of dysentery. So dysentery comes from drinking polluted water. Water can have, what now? So water can have infections in there. Y'all know my fiance and I, we're big hikers, we're big campers. We bring a life straw with us because we can drink water from local water sources like ponds and things as long as it's moving. But we have the life straw because it disinfects. It takes all that stuff out. So you want to take things out. What things could potentially get us sick?
Fish, follow.
Well, we're gonna hope the ball went in the water. Yeah. What pathogens?
Ligma.
What? Okay.
Zika virus.
Dirty water.
Not Zika.
Dirty water that has soil and fertilizer.
Yeah. So things could get us sick. What else?
Lead.
Lead could be in the water. We talked about Flint, Michigan in here where lead is in the water. We're trying to figure out what to do with that situation, how to filter it out. The issue is it's in their pipes. The lead's coming from pipes and other sources. So you disinfect. You can get things like cholera, dysentery. You can get all these really bad sicknesses. So you disinfect. Good job. Let's get the water here. Okay. Tell me, what happens after disinfection? Where does it go?
Go clean.
What now?
It goes to clean.
To humans?
It goes to cities.
Yeah. Yeah,
It
it's
goes to a storage.
possibly. Mainly it's routed. It is storage, but it's routed to us. It's routed to our faucets. It's routed to the drinking water we have over there.
Where?
By the bathrooms, that's fountains.
Oh, you're just putting up the wall.
I got water from my cup. So that is the process. Did y'all know, hey y'all, focus up here please. Did y'all know we had that many processes to filter our water? No? Yes? Give me a thumbs up. Give me a thumbs up if you knew that entire process already. Give me a thumbs to the side way if you kind of had an idea of how it worked. Awesome. We learned some stuff today, y'all. Okay. So, we've got all this done. Now we've got to test that water. So, think about yesterday, they were testing the water. The lady had, our engineer had, thank you. The engineer was testing water. She was going in faucets saying that, you have houses that are 50 years old to 100. There's stuff in there. So, most of the larger cities in the U.S. use, hey y'all, can you fix that? Thank you. Y'all, most of the larger cities, they get their water from surface water. What does that mean? What is surface water? Has anyone heard that term? Robert.
Lakes and ponds.
Yes. So lakes, rivers, reservoirs. We have here in Arizona, if y'all have ever been to the Desert Museum, you'll see it. Is it? Yeah. You'll see them at the Desert Museum. We have the big aquifers we use, the big ponds we have that we get water from the Colorado River. Have y'all ever seen those?
Yo, there's some at the Grand Canyon too.
Yeah.
I think you just press a button and the water comes out like you drink it.
Oh, that's cool. That's really cool.
What's a reservoir?
So a reservoir is just a thing to hold the water. We have the Hoover Dam, which we get a lot of electricity from, hydroelectricity. So at one point, Arizona, hey y'all, focus up here. At one point, Arizona, we were using more water than we were pulling in. So is that sustainable? Let's think about our vocab term from yesterday, sustainability. If you are pulling in more water than you have, are we going to be able to do that forever?
No.
No. So now we have these huge reservoirs that we're pulling in. We've had a lot of water saving initiatives. So water taken from any source with the, especially surface areas, they're going to have a little dirt, some leaves, some sticks in there. Because then they're not contained, they're not in anything, they're going to have that. So that's why we have these treatments. So they can also contain the pathogens. So untreated water is called, who can tell me? What's the term for it?
Yeah.
Not contaminated, it can be.
Crusty water.
Gray water.
Not crusty.
Gray water.
So, okay, let's think about it as a cooking thing. So I have a piece of chicken that I've done nothing to, it is just off the chicken. What is that called before it's cooked? Raw. So think of raw water, or think of untreated water like that chicken, it's
Distilled
raw.
water. Distilled.
Well, it's not distilled yet. It's getting there.
Oh, I don't
So it is raw water. It has not been treated. It has not gone through the process. So remember that. Think of it as almost like the cooking process. So that raw water, which is this, goes to a treatment facility. So most states are responsible for making sure the water meets regulations. So our state has regulations for what can be in our water. So do you think they're going to allow dirt and sticks and leaves in there? No.
Yes.
What about lead, pathogens?
No.
We don't want that. We're going to get sick. So the water flows through all these processes in our containment facility. So I'm going to ask y'all some questions, and you're going to respond with true and false, or true or false. So this is how we're going to do it. We're going to be able to get up for this one. So over here, if you agree, it's going to be true. If you disagree, or if you say true, we're going to get up here. If you say false, you're going to go over here. Everyone has to get up. If you're on this seat and you say true, you still have to get up. Okay? Check our time. Okay. Yeah, I know. I'm going to fix it. Okay. Thank you. Okay, true or false? True here, false there. One way to remove particles from water is to let it sit for a long time. Come on, get up. One way. So remember, think about sedimentation. Think about how density affects our world. True or false? Everybody has to participate. Okay. So, hey y'all. So the general consensus. Here, Amelia, where are you going? Are you true or false? Thank you. So we all say that removing particles from water to let it sit is not a way of filtering water. Well, Juan and Cameo, and apparently Juan, okay, y'all have already chosen. This is a way. Remember I said think it's more dense. It'll go to the bottom. That is a way of filtering. That is part of coagulation. Okay? So that one is true. Okay. Okay, listen up to this now. So, hey Taylor, please leave that alone. Thank you. So, listen to this one. After it is pulled from the water source, the first step in water treatment is to add powder to the water, known as coagulant. True or false? The first step in water treatment after it's pulled from the water source is to add coagulant to the water. True or false? After you've pulled,
No.
hey y'all, after you have pulled the water from the water source, the first step is to add coagulant to it. Ooh, we've got a split. Here, Cody, please get down from there. Thank you.
That has a bit shorter.
We have, think about it. Okay, before we all make our final decisions, water source, what's making all this separate and clump together? So, step one, after it's pulled from the water source, we are adding coagulants. So is that true or false?
True.
So we have our first source, we have the water source here. And this is step one where coagulant has been added, so that is true. So the first step in water treatment is to add a powder to the water, that is true. Okay, let's go on to the next one. So if you're still on the false side, you should migrate over to the true side.
Tree side?
The true. Come on, y'all.
The troopers.
Liam, stop.
Okay. Hey, y'all. Step for the table. Thank you. Okay, listen up to this one. Remember, true side, false side. Filtering and you haven't even heard it yet. Go back. Filtering and disinfectant are not important steps in drinking water treatment. Is that true or false?
I don't know. I'm just gonna go to this side.
Filtering and disinfectant are not important.
You're supposed to. You're not special.
Awesome job, y'all. That is false. Awesome job. No. Filtering and disinfectant are huge parts. I mean, that's what our system is. That is the main point of our water system and our water treatment. Awesome job. Okay, listen to this. Hey, Cody back there, please stop. Okay. True or false? Environmental engineers have the job of cleaning up water to make it drinkable for our community. True or false? Environmental engineers have the job of cleaning up water to make it drinkable for our community. What do we think?
You know what? I'm against popular opinion.
What do you think, Liam? Don't give opinions, go through your ideas.
But they all think it's right, so I should go ahead.
Awesome job, y'all. Again, majority of, hey y'all, you are getting awesome at this. Majority of the class, yes. That is what they do. Not all of what they do. That is a huge part of what environmental engineers do, especially if they focus on water resources. Okay, we have a couple more. Okay, let's listen up. True or false? Environmental engineers only work with new drinking water treatment facilities. So, they only work with facilities that are new. True or false? What do we think?
Rupert, why do you walk like this? You walk like you're like... ED stamping.
Hey, awesome job again, y'all. Hey, y'all, focus up. Liam. work with new facilities. They work with any existing, hey y'all, they work with any existing treatment facility. They don't just say, new facility, let me set y'all up and go on my merry way. They do routine checks. They have to come back. They have to say, this is doing well, let's check, let me get a sample. Let me make sure. They can also come back if there's an issue. If maybe, hey y'all, folks up here please. So maybe people around the area are getting sick and we're trying to figure out why. They will look at the water treatment facilities to find out why. Awesome job. Okay, last one. Thank you. Texas and California consume the most water out of any other state. So listen up. Think about elements. Texas and California consume the most water out of any other state. One, Texas is humongous. Texas is huge, so think about the population there. Think about California in a drought. What do we think? Hey, come here. Ooh, class is split on this one. Okay. Since we are very split on this issue, I want one person from each side to defend.
I got this.
Okay, Liam. Okay, Liam, well, we're going to talk to each other. Cypress, you can defend yours. Liam, tell us why you think this is true.
Okay. Because California and Texas are very, very hot places.
Okay.
So people need more water because of the hydration and stuff.
Okay.
Also, they're big,
Uh-huh.
so that the cities need more water to keep running.
Okay.
Sewers and whatnot.
So high population. Thank you. Tell me why.
Sure has a high population, but
Uh-huh.
maybe in like Japan or China where they have more
Here, Liam.
people,
Let's pay attention.
where they have more people in the population.
Where?
Japan.
Here, we're focusing on the U.S. right now, though. That is a good argument. Yeah, that is a really good argument. Are you going to jump ship? Okay, move on over. Someone over here defend.
I was going to do the same thing. I was going to
Hey, y'all.
like how you guys.
Someone over here defend. Why are you false? Why do you say absolutely not? That is not true. Marisol, tell me why you chose false.
No, it's her birthday. Wait, we have something.
Come on, tell me. Why do you think it's false? Don't know. I'm going to come back to you. Matthew, I've already called on you a lot today, actually. One. Hey, y'all. Listen up, please. One. Tell me one. I don't know. Tell me. Why did you choose false? Because it's better. Okay.
Against popular opinion.
Okay, y'all. Cody and Vincent, please cut it out. Thank you. Someone over here, support Jasmine. Support your thing.
Why are you not choosing this?
If you're going to take a stance, you need to believe in it, and you need to support it. What now? Hey, y'all, I cannot hear Jasmine. Please listen. Thank you. Go ahead.
Wait, I don't know.
Why do you
I
think?
think I'm on the wrong side. I don't know.
Okay.
I'll defend you.
So let's talk about it. I need everyone paying attention up here. Thank you. Okay. So let's think about this. So Texas, like I said, is large. Texas has a very high population just because they have huge cities there, but also just because of the land mass itself. Here. So California. Think about LA. They have some of the most populated areas. They have some of the most populated cities. Yes.
California is the most populated in America. Right?
Exactly.
This is right.
I actually do not know that. I would argue.
It's true.
Yeah.
He told me it. I have no idea. I
Okay.
don't know which part of America California is on.
We're touching California.
We are?
Yeah. Yes.
Los Angeles is popular for like, because of the Universal Studios.
Yeah. Instead of Disney, they're the Universal
Oh,
Hollywood.
I met someone.
Okay, let's focus. We're not getting on a tangent today. So, okay, everyone can sit down. Once we sit down, I will tell you the answer. Get back to your seats, please.
Okay. Now.
Okay. So that is false. I mean, that is true. California and Texas have the largest water consumption in the U.S. And it is because, like I said, they take up so much. They have such high water consumption and such high population. Okay. So what I want you to think about here, Devin, get set, please. Thank you. So, class is almost over. As our closing, what I want you to do, I want you to, in your groups, really quick, and I'll pass out paper. I want you to write down what you think the most important part of the water system is, of the water process. One per group. Hey y'all, one per group, put your name on it. You'll hand it to me as you leave. Tell me what you think the most important part of the water treatment process is. Once you finish that, if you have time, tell me how you would improve it. So use your knowledge we went over from the water system. Think about that. Think about the water treatment system. Think about, here, you can join their group. Tell me what you think the most important part of our entire system is. What we just absolutely cannot get rid of. Here, Cody. Get back to our seat, hon. Thank you. So do that. Put everyone's name on it. Put the period on there. And you'll hand it to me. If you have time, once you've located the most important part, be sure to tell me one thing you can improve or add. Okay, let's talk about water. Okay, take your head off. Let's talk about water. So, talk about water is the most important part of the water treatment.
Yeah, I don't think you can hear water.
So if you have time, tell me how you would improve it. Right now, I want you to tell you about the most important part and why. So is it disinfectant because it gets rid? Hey y'all, is it disinfectant because it gets rid of other things? Is it the coagulant part because it helps get rid of gets rid of sediment, debris? What do we think? Good job, y'all. Awesome. Sorry, y'all. Good job. Okay, again, when the bell rings, be sure you get these to me as you leave. Just get one person from your group to hand